right, interpreting the unit rate as slope 3-3. This should be an easy section. We're going to cover two sections. What we're doing today is they are exactly the same as each other, so this should be pretty simple. It's the same as what we've been doing, actually. They are all this. You work them all the same, just have different names. So, a rate is a comparison of two quantities that have different units, such as miles an hour. A unit rate is a rate in which the second quantity in the comparison is 1 unit. So if I took hours and inches and made them 1 unit, it would be inches per hour. You always do the y. You always do the y to the x. So if I want to find slope of the graph using the points 1, 2, so 1, 2, 5, 10, go over to 5, go up to 10. There's two ways I can find that slope. I could either use the formula with the x and y 1 and x and y 2, or I could just rise over run. So starting at 2 to 10, that would be 8. If I ran from 1 to 5, that is 4. Reduce that, and I get 2. Okay, now so that's how I found my slope. All right, it says remember that the slope is the constant rate of change. So what's that mean is, remember that slope is the rate of change. They are the same. So B, find the unit rate of snow in inches per hour. So what is my unit rate? It's the same as the slope. And the slope is 2, so my unit rate is 2. The only difference between slope and unit rate is unit rate has a label. And we're going to do that. Y per x, that's inches per hour. Okay, so that is 2 inches per hour. A little slash means per, so you don't have to write it out. I guess you could put IPH, but no one's ever heard of that. So, inches per hour. All right, now it says compare the slope of the graph. Sorry about that. Compare the slope of the graph. And the unit rate of change in the snow level. What do you notice? Well, what is the slope? It's 2. What is the unit rate of change? It's 2. So if you were to compare those, you would say they are the same. Okay, the same. All right, moving on. Graphing proportional relationships. All right, graphing proportional relationships. The thing that we know about a proportional relationship is the line that it makes. We've learned about proportional lines, a proportional graph. It must start at 0, 0, and it must be a straight line. All right, that's what we know about proportional graphs. Shows a proportional relationship. So it says you can use a table and a graph to find the unit rate and slope that describe a real-world proportional relationship. The constant of proportionality for a proportional relationship is the same as slope. So, okay, so the constant proportionality, we did K equals Y over X. Okay, sound familiar? Like I said, it's all the same stuff. So, every 3 seconds, 4 cubic feet of water pass over a dam. Draw a graph of the situation. Find the unit rate of this proportional relationship. So, if we make a table, I do every 3 seconds, 4 feet of water. So that's 3 seconds per 3 seconds per feet, or 3 seconds and feet. So that is, time is always going to be on top in your table. Okay, it's just always on top. Now, so when we do y over x to get our label, it will be feet per second. Y to x. Get a label, y to x, feet per second. All right, if we draw a graph, all we have to do, let me finish the table. To get the rest of that table, all they did was times 2 there. You got 6. Here they just times 3 times that one. 4 times 3 is 12. 3 times 4 is 12. 4 times 4 is 16, and you can see that this one was times 5. Okay? All right. To get the graph, each one of these is a coordinate. So my first coordinate there is at 0, 0. If I go to 3, 4, I can see that I actually have a point there. Next even one, 2, 4, 6. These, if you notice, you're going by twos. 2, 4, 6. Go up to 8. Next perfect one is at 12, 16. Okay, so now I can find the slope by doing rise over run. So if I would have gone this way, that would have been 8. So that's 2, 4, 6, 8. Run 6. That reduces to 4 over 3. Now if we just did y over x, like k equals y over x, what is my y? It's 4. What is my x? 3. So that would have been 4 over 3. All right. So my unit rate is 4/3 cubic feet per second. And you can look at your graph. Here's my y, here's my x. That tells you your label. Cubic feet per second, y to x. All right, number 2. Thomas rides his bike at a steady rate of 2 miles every 10 minutes. Graph the situation. So 2 miles. Where's miles at? It's not on the x, it's on here. So if I can go up to 2, let's see, 1, 2, 3, 4, 5, they're going by ones. 1, 2, go out to 10 minutes. It's right there. I can draw a straight line. Look at there, I did it. All right, graph the situation. Find the unit rate. So it's just y over x. What was my y? 2. What was my x? 10. So that reduces to 1/5. If I do my y to x label, that is 1/5 minute per, mile, 1/5 mile per minute. So they run 1/5 of a mile every minute. So how long would it take them to run a whole mile? 5 minutes. Okay, that's pretty fast. All right, next, moving on. Using slopes to compare unit rates. Okay, sometimes they're going to give you a table and a graph to compare. They may give you an equation. Remember, this is just y equals kx. Once you find k, you just plug it in. They may give you the equation and a table to compare. They may give you all three. One of these may be the table, as it is in this instance. Okay, so if I look at this, it says use the equation y to make a table. All they did was plug 1 in for x and multiply. You get the same thing. 2 times 2.75 is 5.5. 3 and 4 and so on. Okay, so that gives me a table to look at. Now it says use the table to find the slope of the graph. Well, that's just 2.75 over 1. Okay, but k in a proportional relationship is slope. So we didn't even really need to do this. They already gave us the slope right here. But if it tells us to do it in the instructions, we're going to do it. Okay, and if you notice, if you do it for every one, they all come out the same. And that must be true. They must come out the same. But it's going to, because we plug those into x. Now to find the slope of the graph, we're just going to use rise over run. So if you start here from my first point and go to here, that's my next good point. That's rising 10, running 2. I'm sorry, that is not 2. That's counting by 2. Counting by 2s. So that is 2, 4. So that's 10 over 4. Here's 10 over 4. Since it has a decimal here, we're going to make it a decimal. So that's 2.5. So we're going to compare 2.75 and 2.5. So which one is pumping more oil? The one that's 2.5 barrels per hour, or the one that's 2.75 barrels per hour? Okay. So the graph represents B. This represents A. So, well, A is faster. All right. Same thing here. we have a table, so we can find slope. Just doing y over x. So my y over x here is 425 over 1, which is just 425. Okay, here's the slope in that one. That is, so what is my label here? Miles per hour. So that's 425 miles per hour, or MPH. And everybody knows MPH. So 425 miles per hour, or 375 miles per hour. Which one's bigger? Well, 425 is. Okay, so plane, what is this? B is flying faster. This was A, this one was B. So plane B is faster. Okay, a couple of problems similar to homework. It says give the slope of the graph and the unit rate. Well, miles is what? Miles is my y. Hours is my x. If I use y over x, or I can count rise over run, this would be 5 over 6. So my slope is 5 over 6. All right, and then it says, what's the unit rate? That would be miles per hour. 5, 6 miles per hour. They're the same. Here, my x, here's my y. I could do rise over run, or I can just do y over x, which is 5 over 4. 5 over 4, excuse me, label y over x, y to x is miles per hour. That is my unit rate. So slope and unit rate are the same. You'll have problems like that on your homework. Okay, write an equation relating the variables in each table. So to write an equation, you're going to write the equation in the form y equals kx. These are all my x's. There's an x, there's an x, there's an x, there's an x. There's a y, there's a y, there's a y, and so on. Okay, that's why it has x and y right there. So to find k equals y over x. So 15 over 1 is 15. Okay, 30 over 2 is 15. 60 over 4 is 15. So what is my k? K is 15. So I'm going to plug in 15 for the k. So y equals 15x. Same thing here. I would just do 6 over 16 reduces to, what's that? Divide by 2 and you get 3/8. If you do 32 over 12, that if you divide both sides by 4, you get 3/8. So k is 3/8. So y equals 3/8 x. Okay, and that's all how you write an equation. All right, moving on. Direct variation. It is the exact same thing. You find it the same way, and everything. Nothing changes. All right, the direct variation is the relationship that can be written as y equals kx. That's what we've just been using. So direct variation and constant variation, constant proportionality, slope, they're all the same. All found the same. They don't all mean the same. All right. So let's go straight to an example. All right. The only difference in solving this is that we have to do y over x for every one of these. Okay, so in our calculator, we're going to take 0.95 and divide it by 0.5. If you do that, you get 1.9. Then you're going to take 2.375, divide it by 1.25. You should get 1.9. Then 3.8 divided by 2, 1.9. If you do 8.55 divided by 4.5, you should get 1.9. If you do 45.6 divided by 24, you should get 1.9. Okay, and if those are all the same, that means you have direct variation. But if one of those is not the same, then you do not have direct variation. So it says if you do, write the equation. What's our equation for them? Y equals kx. So y equals 1.9x. Okay. So we can apply the graph of the direct variation. Same thing. It says one brand of motorcycle uses oil to get gasoline ratio as shown in the graph. The amount of oil that should be added varies directly with the amount of gasoline. Write the direct variation equation that describes the relationship. Use the equation to determine the amount of oil that should be added to 6.5 gallons. So we need to find what our slope or our K is. So right here at 1,1, I can go to 2,8. So I'm going to rise. So this is going by halves. This is going by twos. So if I rise 2, 4, 6, so that's 6 over. Okay, so that's 1/2, 1, 1.5. All right, I don't really like that. That doesn't really go even. Let's see if we can find something that's more whole. Let's go from this point to this point. I think that's going to give us something better. So if this is 8 to 16. So 8 to 16 is 8. And from 2 to 4 is 2. Reduce that, you get 4. So K equals 4. So we can write our equation. Y equals 4x. So it wants to know at 6.5 gallons. So we just plug it in. Y equals 4 times 6.5. So if you do that, 4 times 6.5, Y equals 26. So that means if we went out to 6.5 way out here, this line would be at 26 here. Okay, that's all that's doing. All right. Determine whether the data set show direct variation. If so, write an equation. So just like on your homework, you're just going to take bottom number divided by the top number. So 4 divided by 3. 4 divided by 3. 1.33. So 1.33. All right. 2.4 divided by 5. 2.4 divided by 5. That's 0.48. Well, that's different. So this is no. And you don't have to go any further. Do the next one. 160 divided by 8 is 20. 300 divided by 15 is 20. 560 divided by 28 is 20. And 940 divided by 47 is 20. Okay, and this is how you show work on your homework. So all those were 20, so yes, we do have direct variation. So we need to write the equation now. So y equals 20x. Okay. All right. The number of cups in a measure varies directly as the number of tablespoons. Write the direct variation equation that describes the relationship. Use the equation to determine the number of cups for 56 tablespoons. So we're just going to rise over run and get our slope. 4 to 8. So that's, I don't like that one. Let's go. Well, we're just going to have to do that. We're going to have a decimal. So we'll go from here to there. That's 0.25. So 0.25 over, this is going by 2's. 2, 4. Okay, so we're going to take 0.25. Okay, that is our K. So if I want to change that to decimal, it's 0.25 divided by 4, which is 0.0625. 0.0625. Okay, that's 0.0625 cups per tablespoon. If I wanted to do unit rate. All right. So now I can write an equation. Y equals 0.0625 x. So if I want to know how many, the number of cups in 56 tablespoons, so I just take that number and multiply it times 56. So y equals 0.0625, plug in the 56. So 56 tablespoons makes 3.5 cups. All right. I'll do one more example, then you'll have time to work on your homework. So this is direct variation. I'm just going to do 62 divided by 20. I get 3.1. 93 divided by 30. I get 3.1. 155 divided by 50. I get 3.1. 496 divided by 160. And I get 3.1. So that is yes. I'm going to write the equation y equals 3.1 x. Okay? Y over x every time. It's all the same. Alright, so work on your homework. Homework is front and back. That's not that many problems. And that's all. Now, on the homework from last night, if you like the grade that you have, turn it in. If you do not like it, keep it. I will do a grade replacement. So if you know you have a grade lower than what you made on the worksheet from last night, turn it in and I'll trade it for that grade. I'll be back tomorrow. Good luck. Have a great day.